Hi, everyone. Welcome to the Art of the Possible series. I'm Nihali Niyogi. I'm a principal cloud solution architect at Microsoft. And this video is part of a playlist on integrated NVAs in vWAN. And today's topic, more specifically, is on VMware SD-WAN. With me, I have few amazing guests and panelists. I have Cynthia Treger, who is a global black belt focused on Azure networking at Microsoft. And I have two amazing guests from our partner VMware. I have Vivek Archer, who is a senior product manager, and I have Luke Hoffer, who is a consulting solution architect from VMware. And I also have a very strong Q&A panelist across broader Microsoft focused on Azure networking. So welcome, everyone. Happy to have you today here. And as you can see on my screen, this is the official Azure documentation about NVAs in virtual WAN. And today's topic I want to kind of highlight here is VMware SD-WAN. We do also have a lot of reusable architectures. So if you haven't watched the part 1 of this series, which is the kickoff session, we did a deep dive on various scenarios in vWAN Hub. And of course, there are lots of different partners that we have covered in this series, including different security and SD-WAN partners. So with that, I will turn it over to you, Vivek, for the special presentation today. Thank you.
Okay. Thank you, Nihali. Hi, folks. This is Vivek Achar here. I'm joined by Luke Hoffer. I'm a product manager in the VMware SASE team. VMware, as you know, is acquired by Broadcom, and formerly we were the VeloCloud. We were known as VeloCloud. We were one of the pioneers of SD-WAN, and then we were acquired by VMware, and then since then VMware was acquired by Broadcom. I think the VMware acquisition for Velo happened in 2018, and I think folks who follow news would have noticed that VMware got acquired by Broadcom late of last year. So if Luke, if you can go to the next slide. So traditionally, why SD-WAN? So when the traditional WAN networks were deployed, customers had a few challenges. One, it was very tough to scale bandwidth. It was very expensive. And as the application landscape changed, the WAN was not capable of handling it, right? And then there were, multiple other challenges where, as customers had to, or enterprises had to deploy devices on their WAN network, managing them, provisioning them, troubleshooting them was a hassle. One other, kind of transformation that happened across enterprises, and I'm talking a little bit back in time, is enterprises started consuming more and more SaaS apps, largely driven by, say, Office 365 and Salesforce, as well as customers started to move to, public cloud. All this kind of gave impetus to SD-WAN, and VeloCloud as a startup was founded to solve this problem, right? And some of the early innovations on the product is how do we solve for some of the day zero, day one issues and make it very simple for customers to configure, provision, manage these devices. Uh, when out of the box, when the can the solution detect applications where you categorize what that application traffic is and then provide the best treatment on the WAN. And then, the WAN again, initially it was all about the cost. So it was using business class internet also as a WAN. And when you use business class internet, how can you, constantly measure the WAN for its performance, for its latency, loss, jitter, and then depending on the application, give it the right treatment. Also, a lot of customers wanted to use multiple links, multiple links in terms of hybrid connectivity. It could be MPLS internet. It could be dual internet at the branch locations. And how can you then do load balancing and utilize those links at hand to get the right treatment for their user application experience. And last but not the least, a lot of customers also had requirement from a compliance and M&A perspective where they would segment their networks on their traditional WAN, and they wanted to continue to do that with SD-WAN. And also, now that the fact that your branch is kind of having an internet-bound circuit, you're also worried about security. And that's where the VeloCloud or VMware SD-WAN shines. Luke, if you could go to the next slide, please. Where customers can deploy the solution without knowing the intricate details of CLI, how to configure and monitor and provision these devices. So it's a very simplified deployment that a customer essentially can do with our solution. And I'll go into the details a little bit later in the next couple of slides. But that was a big enabler for customers as they started deploying hundreds and thousands of sites to do it in a very simplistic fashion without necessarily needing a truck roll and sending a technical person at that remote location to deploy some of these SD-WAN branches. The second key aspect, as you see there on the slide, is assured application performance. So the ability to detect, give it the right treatment on the network. And I will talk about our secret sauce and differentiator as to how we are able to achieve that. And then, just in terms of, cloud deployment, how can we, provide that best application experience for customers if whether they use SaaS applications, IaaS applications, and how do they consume this entire SD-WAN service? It's also offered over the cloud for customers to essentially consume it as well. And then just in terms of the security aspects or the use cases that I spoke about, how do we essentially make it much more simpler for customers to use and consume security at that remote branch location. So we'll go into each of these aspects a little bit more in detail, if you allow me, and then we will get into so the Azure vWAN aspects as well. So very quick plug. We have been Gartner Magic Quadrant leader for the last 7 years, and since the time Gartner had this Magic Quadrant. So just wanted to call that out, and that's going to be my last marketing slide. Luke, if you can go to the next one. So we, in our VMware VeloCloud SD-WAN solution, have kind of three major components. So the first one is the edge. So the edge that you see, sorry, it's noted as number 2 there. So the edges are the devices that reside in the customer prem, in their data centers, could be in their campuses, as well as public cloud. So these are available both in physical or virtual form factor for customers to use. And these physical edges also have the ability to have Ethernet as well as 5G, right? And the virtual form factor naturally only has Ethernet. And this is the component to which customers would connect their WAN circuits to. The second component is the VMware SD-WAN gateways. So that is noted here as number 3. So the VMware SD-WAN gateway essentially has two functions. So it has a control plane element, which is, think of it like a BGP route reflector, where it has where each of the edges, when they connect, they provide their prefixes or the branch prefixes to the the gateway, and the gateway has that visibility across that enterprise. The second kind of critical element with the gateway is that the gateway also is a multi-tenant a data plane element. Uh, and this is, one of our key differentiators, where this gateway allows customers as well as our partners to essentially on-ramp traffic towards the cloud, whether it being SaaS or IaaS, and then connected back to the enterprise applications. And thirdly is the orchestrator. So the orchestrator is that central management portal. So think of it like your, Azure portal, which provides you access, into your Azure environment. In a similar fashion, the orchestrator essentially allows customers to, configure, monitor, troubleshoot, their SD-WAN fabric. So the orchestrator also allows, like things like configuration model, which is kind of hierarchical, where you can create a profile, and depending on the branch, size, you can essentially, you can create profiles and edges as well. And as the edges, boot up, they come online and get, zero touch provision from the configuration that the orchestrator has. So it is very easy for customers to deploy and provision these devices. I want to spend a little bit more time on the gateway. So, Luke, if you could go to the next slide. So the gateway, as I said, is a control plane element. So, it is the route reflector. Think of it like the BGP route reflector. So that each of the edges, they set up tunnels to the gateways. Now we have both the orchestrator and the gateway could be, a customer could choose our hosted offering, or, if the customer has certain compliance and security reasons and they need to host it on-prem, they also have that ability as well. But in the case of the gateways, we host the gateways in our POPs, and we also have, partners hosting these in their networks, for their end customers as well. And the gateways, since they are multi-tenant data plane elements, customers had, varied use cases where they use the gateways, where, in some of the early customer deployments, they had a hubless design, and the gateways essentially allowed them to have connectivity between branches. So assume if it is one branch needing to communicate with the other branch, they could essentially go via the gateway to the other branch. We also had, or have partners who host some of these gateways. And if they offer some UC or security services in their data centers, they can also allow customers to on-ramp to those services. But at least for this discussion, the most important piece I wanted to highlight is that we host these gateways in our POP, right? So we have close to, last count, I think it was 38, and we are growing our POP footprint. So in these POPs, wherever possible, we connect to the likes of, cloud providers like Microsoft, which are just one hop away. So the edges set up, tunnels to the gateway, which think of it like a secure or IPSec tunnel. We call it as VCMP tunnels. And then we run optimization on top of it, which is called as DMPO, or dynamic multipath optimization. And I will go into what that means. But customers, when they deploy these edges, the edges set up the tunnels to the gateway, and that VCMP tunnel is essentially optimized, and then they can connect to the SaaS applications, which are just kind of one hop away. Similarly, these gateways also help connect to, say IaaS interconnect devices like the virtual WAN hub, and I will talk about it, using IPsec tunnels from these gateways to some of those, IaaS interconnect devices. So, and we'll talk about, that, connectivity to the virtual WAN hub in a little bit more detail. But I just wanted to, give or set base in terms of, what the gateways essentially do. Luke, if you could please, I'll take a pause here, see if there are any questions, Cynthia and Nehali.
Not on my side, but thanks for the recap and for the description of the solution.
Okay. Moving on, one of the key capabilities that you'll find with, pretty much every SD-WAN vendor is the ability to detect applications. So nothing new there, but we have the ability to detect, 4,000 plus applications. But a lot of times when you actually, detect applications, it takes a few packets before you can classify, or you can detect an application and then classify it. So we also add intelligence around that, where we want to do it. We ideally want to do the first packet classification and then give that application traffic the right treatment on the network. So in that scenario, we have a few other innovations where we have some learning database where once the first flow might go unclassified, but then further flows to that particular destination will get classified correctly. And similarly, there are, we also interface with likes of Microsoft, and so we have, up-to-date database if the traffic is going to, Office 365 applications or, G Suite and such. We have a database which essentially maintains a set of, those destination networks where traffic might be going towards, and then classify the application and helps in that first packet classification. Now moving on to the next slide. So, I spoke about DMP, or dynamic multipath optimization. If you see on the screen on the bottom half, you'll see, edges on the left, which are setting up these tunnels. We call these as VCMP tunnels, or VeloCloud Management Protocol tunnels. Think of it like a secure tunnel, but we are constantly, monitoring these tunnels for latency, loss, jitter. So as these links will see changes over a period of a day, or hours, or across months and years, we will constantly look at these parameters on the WAN network, and then help in augmenting, or doing performance optimization on these links. The second aspect that is very critical is we do per packet steering. So what I mean by that is we are able to measure latency, loss, jitter, and specifically for latency, we can do one-way latency measurement from edge to edge, or edge to gateway. And then we can decide for a particular application traffic, if it is, say Teams traffic and it is latency sensitive, and if the latency for whatever reason has gone up on a particular link, we can steer that traffic onto the other link. And we don't just do it based off a flow; we can do it based off every packet when the traffic hits the edge. Also, very critically, if there is error or jitter, we are able to, replicate traffic. For real-time UDP traffic, we are able to, in many cases, do packet replication across multiple links, and then give it like, think of it like a TCP-like experience, and do on-demand remediation as well. So that effectively improves, that performance. So in many cases, customers have dual links, but there are cases that we have seen, specifically with COVID and remote workforce, that you have a single link and you still want to improve your performance on that particular link. And how do you achieve that? And that's where it comes into effect and helps in generally improving the performance. Uh, and this effectively helps largely in some of the links which might be flaky, in some of the newer deployments where customers have started doing it across satellite links, using Starlink and such. This becomes very critical. But the key underlying thing that you want to take out from the slide is that when it's traffic going from edge to edge or edge to gateway, that is all DMPO. Luke, if you could please go to the next one. So this is just an example where, how DMPO helps with one of the business critical applications like Office 365, could be, Teams call as well. So this slide kind of illustrates how a remote branch, which is in Thailand, connects to a gateway that we host in APAC, and how the performance improved uh, for that application traffic with and without VeloCloud. And the screenshot is more a third party, but this is just to kind of demonstrate how DMPO is effective on customer networks. So that's on the SD-WAN solution, and giving you a bit more overview into what are some of the reasons that customers like us deploy our solution. And now, specifically going into the Azure environment, what are the different ways in which customers connect their SD-WAN, VMware SD-WAN networks to Azure virtual WAN? So the first option that you see, and I was speaking about, our gateways. So the gateways that we host are, some of our partners like, MSPs like AT&T, Windstream, QS Networks host. They could essentially allow customers connectivity to some of, the Azure virtual WAN hub. So we have the ability where customers who used, think of it like, deployments where I am using a hubless design. I'm just, using the cloud gateway in that scenario, the VMware SD-WAN gateway. And how do I connect to, the Azure virtual WAN hub? So that is, one offering that we have. We also have some automation there, which allows customers, in a simplistic fashion to connect their IPSec tunnels from the gateways to the Azure Virtual WAN Hub. The second option that we will talk about in much more detail today is the ability to deploy our edges as managed network virtual appliances inside of Azure vWAN Hub. So this effectively, extends SD-WAN from customer branch networks or campus networks to the Azure doorstep, like inside of Azure, and helps with all that DMPO goodness that we spoke about earlier. So this won't even need that that IPsec connection that we spoke about here, because once you deploy it inside of an Azure vWAN hub, you are effectively extending SD-WAN right up to inside of Azure itself. While we do this, the option three is where customers who still want to have hybrid connectivity, where they could have internet as well as MPLS, use these hybrid circuits to essentially set up a connectivity back to Azure Virtual WAN Hub. The NVS deployed in Azure Virtual WAN Hub, and you could use ExpressRoute as well. And Luke will speak about some of these use cases in much more detail. And one very interesting use case that we have seen with customers wanting more flexibility is to deploy the VMware SD-WAN edges inside of their transit VNet, and then connect it to the Azure Virtual WAN Hub and set up BGP connections over that VNet connection, and achieve something similar as option two, but have a little bit more flexibility for them to troubleshoot or decide on the instances that they desire for. So these are the four options that we will talk about in much more detail. I'll take a pause here. Nihali, Cynthia, Daniel, if you have any questions.
Yeah, I have a quick question. This came up recently for another customer I was working with, but between option one and option two, Vivek, so like the one is the straight up IPsec tunnels. For number two, do you have a published set of ports, UDP ports that get used for SD-WAN? Is that something configurable? How does that work? Or if you're going to go details later, that's fine too.
Yeah, so I think Luke will go into much more detail on the option 2. So when you deploy that using the managed NVIDIA offer, the managed app on the Azure portal, those ports will get opened up. So typically, for setting up those VCMP tunnels, we need UDP 2426, and then typically you'll also open up SSH and SNMP. But yeah, those are the ports that we recommend, and those would be opened up for that managed NVIDIA offer. Yeah,
Got
I
it.
don't know.
Yep. Thanks. So it's just one port. It's not a range for that option, right?
Yeah.
Okay.
Yes.
Thanks.
I have a question regarding option 4. Why do we have IPSec mentioned? Isn't it the SD-WAN overlay as well? That would be extended from the SD-WAN Edge up to the transit VNet?
That's correct. Thanks for pointing that out, Cynthia. That's oversight on my part. That should have been DMPO. I will correct that in the slides. Sorry about that.
And
Okay.
on these options, which one is for managed? Do we have the managed NVA option here listed?
Yes, the option 2 is the one that is the managed NVA.
Okay.
Yeah. Okay, if there were no other questions, I'll hand it off to Luke.
Actually, I do have a question, Daniel.
Sure. Yeah.
So in terms of the, maybe you're going to go over the option 2, which is a managed solution compared to the other options. Is there any differences between features or pretty much like all the same?
All the same. The one difference that we'll talk about later, Daniel, if you'll allow us, is accelerated networking. So it is not currently supported with the managed NVIDIA offer, since we deploy these with V2 instances. So we are in works to create an offer with V5 instance. But I'll go into a little bit more detail if you'll allow us a few more slides.
Thank you.
Cool. Luke, do you want to go to the next one?
Yeah, so maybe just to kind of lay the groundwork for some of the common terms that I'm going to be using here. I'm going to be kind of bouncing back and forth between the slides and the demo as we go through and look at what these different options look like, both from a day 0 and day 1 perspective. But, like Vivek mentioned, the management plane component that you're going to see me interfacing with here is our orchestrator, and it's actually one of those components, like we mentioned, that's hosted by VMware. So from a day 0 perspective, the idea is that any of the control and management plane components that would be used in order to stand up this solution are already deployed as part of the service. So that obviously simplifies things from that perspective, but the management plane and the orchestrator is really the single source of truth from any of the configuration perspectives that we'll be looking at. So there isn't any kind of bifurcated workflows where we configure some things in a centralized management plane like this and other things via local device CLI. Our local device CLI is only for debugging, so there isn't anything that you configure outside of this orchestrator. So you're going to see me pretty much living here the whole time. But from the perspective of the branch edges, so when we're talking about the things that are actually connecting to Azure, so much like these edges that sit along the left side and need to connect to Azure in some way, shape, or form, They're all going to look pretty similar regardless of what we're doing here. And the idea that we've got from the configuration standpoint with these is that each edge contains a profile. So the idea of a profile is really just to provide a configuration template that if we look at the branch edge, for example, all of the common things that I would have for a site, so things like the QoS and traffic steering policies, firewall and IPS policies, those types of things that generally aren't going to be different from site to site, are going to be things that are defined in a template. So that's where I'm going to be doing things like having the basic pointers to say that if I am in a given region, I'll point to a specific Azure region or set of Azure regions, potentially in a given order, and dictates how I'm going to be able to actually connect from the actual branch edge to either the gateway that connects to Azure or to the virtual edge or edges that are going to be living inside of either the vWAN hub or a spoke VNet that then peers with the vWAN hub. So in all of these cases, you'll see that we'll have these pointers, and I'll kind of show how that looks for each of these different scenarios. But the idea then is that these profiles, when we go to actually create an edge, that really the only thing that we need to plug in at that point is anything that's going to be unique to that edge. So things like interface IPs, specific BGP peers, if they're going to be different from a branch scenario, obviously they often are. Not so much in Azure, since a given region, we typically have the same sets there. But that makes it as simple as just saying when I go to create an edge, that really I'm just giving it a name and picking a model. So, in the case of like an Azure Edge, we would be picking virtual and then having a profile that I assign to it to get those things. So the idea there is that once I've got that defined, then really all I need to do when I actually go to add that edge, again, is to plug in the unique attributes, which oftentimes is just going to be something, like I said, like an interface IP. If I've got static IPs, obviously, if everything is DHCP, I can just deploy that way, which in the case of Azure, obviously, we can do that. So once that's done, the edge creates this activation key. So this identifier you'll see come into play when we look at the actual deployment workflows inside of Azure when we're deploying virtual edges. This is really just the way that the edge gets identified when it phones home, because the edges out of the box, of course, don't have any configuration on them and don't really know their identity at all. So the idea is that from a provisioning standpoint, in order to keep that low touch at the branch location, that this can be either a matter of just letting the edge phone home, and based on its serial number in the case of a hardware edge, that the orchestrator will know where to put that and send it its config that way. Or in the case of a virtual edge, this activation key acts as that identifier that can be used in order for it to phone home to the VCO or management plane and identify itself, at which point it will then do things like perform its initial activation, download all of its configuration data, because again, that's all defined in the management plane. There's nothing that we configure locally on the edge. So it'll download all of that configuration, and then whatever software version is assigned to that edge will also be applied from the edge standpoint, so that it maintains consistency with what you've got defined in the orchestrator. So that workflow is going to be similar across the board when we look at these different scenarios, and we'll again kind of refer back to that. But I just wanted to make sure that from a terminology standpoint, that we were all on the same page there. So the first thing that we'll look at is the option 1 configuration, whereby we have branches that are connecting to Azure via one of our cloud gateways. And building IPSec tunnels from the cloud gateways into the vWAN hub. So that VPN gateway on the vWAN hub side should look pretty familiar. So we're not doing anything too out of the ordinary there. So if we look at a given hub, for example, that we've got configured, the configuration on the Azure side is relatively straightforward, in the sense that when we actually define a VPN site for our edge, that we'll just have the IP address effectively and the BGP peer that will live in there. Everything else is effectively friendly names here, but there's nothing really special that you have to do in order to exchange those routes. Now, where that comes into play typically is going to be situations where we might have a region, for example, that is relatively small, or somewhere that that doesn't have a lot of resource contention. You know, obviously the big benefit to using our cloud gateways in this scenario is that the customer doesn't really have to deploy anything into Azure other than building that VPN configuration. Now, you know, the reason that customers might not do this really comes more down to the throughput that can be achieved. So obviously the IPsec tunnels into a VPN gateway have their own limitations, where, you know, really if you need more than that roughly 1 gigabit per second worth of throughput into a given region, you're not going to go this route. Additionally, the performance benefits of DMPO, well, we do get some. So that's one of the nice things about these cloud gateways, is that the things that Vivek was talking about around things like forward error correction and jitter buffering and all that kind of thing are still performed on the last mile, because we've got our cloud gateways here to bookend this. So we still do all of that fun with the DMPO and VCMP protocols from the edge to the gateway. So from a performance standpoint, we still get those benefits in the last mile, which frankly are where 90% of your problems are going to happen. But obviously when we go out in a traditional IPsec tunnel from there, that isn't going to have that same performance benefit for that leg. Now, that said, in a lot of cases, that's not a huge deal. You know, and frankly, more of the scale conversations are what drive us away from this model. Because again, in the vast majority of our POPs, we either have dedicated peering with Microsoft or are at least on a peering exchange that Microsoft is also on. So while that is technically going out to the quote unquote internet to happen with an IPsec standpoint, there's generally not a lot of places for that to break down when we look at this model. But the idea here is that when we define one of these, and we call it in the orchestrator a non-SD-WAN destination, basically just meaning that we're creating this to connect via that gateway. So, you know, we'll look at the example that we've got here. Sorry, was there a question? No, maybe not. So when we create this in the orchestrator, we just create a single instance. And the idea here is that when we build these sets of tunnels off of our gateways to a given vWAN hub, that these tunnels can actually be consumed by multiple edges in the SD-WAN overlay. So that's one of the benefits of decoupling this, is that we don't have to replicate this for every single branch. So if I've got 5,000 branch locations out there in the SD-WAN fabric, I could realistically point all 5,000 of them to the same set of tunnels and have them all leverage that. So when I create this, it's pretty similar on the orchestrator side, in the sense that all I'm going to be doing is plugging in the Azure IP for the VPN gateway that's associated with that vWAN hub. Obviously configuring my my VPN settings to match what is there on the Azure side. But once that's done, then effectively that model is going to do a couple of things. So first of all, we're going to figure out what gateway to use, because again, we've got these POPs all over the world. And the idea that we've got for performing this, since we could have multiple edges consuming it, is going to be to put this gateway as close to the Azure region as we can. So the first thing we actually do when we provision these things in the orchestrator is we geolocate this IP address to figure out what region we're actually going to be connecting to. And as a result, then we actually will determine based on that which gateway is going to be closest to that region. So that, for example, if I'm in the US East region, then you know, I might have a gateway picked out of our Northern Virginia POP, or wherever that happens to be from a geographical standpoint, closest to where we geolocate that IP to. The idea there again being that all the sites that are going to be connecting via the SD-WAN fabric to this gateway will then land effectively right on the front door, thereby minimizing again the amount of time that we're actually going out to the non-optimized internet, we'll call it, when we exit the overlay and traverse these IPsec tunnels. After that, then we can actually establish those tunnels. In our case with vWAN, obviously we generally will want to use BGP, so we can configure the actual BGP peering to Microsoft here. I only set up one peer just because I was hurriedly doing this morning just to have this set up for this call. But the idea is that we'll then peer with the vWAN hub via that tunnel. So that effectively provides everything that we need for this right half of the equation to say that we've got our vWAN hub and our SD-WAN gateway set up. So then from the branch edges perspective, like we looked at before, we can use our profile so that whatever branches we want to have pointed to that, we can actually look at the VPN services section here and just say that I want them all to connect to this Azure example NSD that we set up. So that is going to be what tells the edges that consume this profile to build their overlay tunnels to this gateway so that they can access the routes being advertised in Azure. So once that's done, in the example of this edge, I've just got a single edge that is deployed here that's consuming that tunnel. And if we look at that edge, really the only subnet that we're going to be pumping into vWAN is going to be this this loopback address, this 10.333. And once that's stood up, then the idea is that if we look at our routes inside of the hub here, that we'll be able to see that 10.333 route as one of the VPN routes that exist inside of the default route table. So the peering that we did via that gateway is going to be where we learn that. And apparently, oh, there we go. So you see this 10.333 route that exists here. These other routes will come into play later. We'll look at those. Those are for the other peering options. But again, by virtue of the fact that we are connecting that branch via the overlay and defining the non-SD-WAN destination that we wanted to connect to here, then we build that overlay tunnel again from the branch to the gateway, and the gateway advertises our branch prefixes into vWAN. So I'll pause there. Are there any questions on this particular method of connecting to vWAN?
Yeah, just a quick question from me. Is this a scenario you often see with your customers?
I'll say that this is less common. So again, generally the places where we'll see this, and it's stuff that I often will see kind of intermingled, where the other options that we're going to talk about get used in the big primary regions. So just as an example, I've got a customer that they're in the data management business, and they've got their two main regions in US East and US West, and they don't use this method there. However, they have a dev team in India that has a small footprint inside of one of the regions inside of India. And because it's dev, so they don't necessarily care about having that end-to-end performance, and they also don't need more than a gig of throughput into that region, then just in order to minimize the footprint and complexity, they just build these tunnels for that region. So usually we see this for the less, I guess, prioritized region where they either A, don't need the throughput, or B, it's not as mission critical overall from a business standpoint.
Okay, thank you.
All right, I will move on, excuse me, to the next one. So the next one is the managed NVA offering. So just architecturally, the way that we will be kind of thinking about this is that, like a lot of the managed NVAs, when we talk about a managed NVA, we're talking about actually two instances of our virtual edges per NVA. So the idea here is that we will deploy those. Obviously, the nice thing about managed NVA, or one of the nice things about managed NVA, is that Microsoft handles all of the redundancy and making sure that those are deployed across different zones and that kind of thing, so that we can ensure resiliency when we're talking about this. But the idea is that we'll have those two different edges, potentially more if we need to scale out. We've got a separate section where we'll talk a little bit more about the actual scale and how we do that, the different dimensions we can scale in. But the idea here is that we'll deploy those two, and then we use a mechanism that we call clustering in order to provide the both the failover as well as some of the scaling metrics that we've got there. And when you think of a cluster, in our parlance, that's not doing any kind of shared state or anything like that. It's really just an active-active model whereby the edges, acting somewhat autonomously, will still be able to facilitate failovers via our control plane between them, so that if there is a failed cluster member, or in some of the maintenance scenarios that we'll talk about, that we can move edges around. But the general model involves these branch edges down at the bottom, and having them, for example, connecting to one of these cluster members, and from that cluster member then advertising their prefixes back into the vWAN hub. So the idea there again is that that we'll have one of those cluster members connected to by a branch, and that's how they'll get their connectivity. Now, that said, the cluster itself, again, is really just going to be something that we use as a logical container. So if you look at what a cluster actually is, excuse me, from the perspective of our orchestrator, it really is just going to be the container that we use to define those edges. So if I look at an existing cluster that we've got in here for one of these NVAs, literally I'm just giving it a name and picking which edges want to be in that cluster. So it's really our control plane that handles things like assigning a specific cluster member to an edge and failovers when one of those cluster members either goes offline or loses its connectivity back to the vWAN hub, anything really that causes it to lose its LAN side routes. Or vWAN hub side routes in the perspective of the managed NVA. So those are all handled by the control plane and not something that you need to configure. But what that does is allows me to simplify and say that if I look at a branch configuration, where similar to what we saw before with defining the non-SD-WAN destination, I can define this cluster as a single object so that the edge doesn't need to worry about any of that. So, both allowing me to say that I've got this single container, or, that might be one NVA, it might actually be multiple NVAs, depending on how I've scaled this. But the branch edges don't need to know anything about that, because really the control plane will figure out assigning them to the correct cluster member. So that's what actually gets deployed when we deploy the managed NVA in the vWAN hub. Looks like there's a question, Cynthia.
Yeah, thank you, Luke. So here we have 4 instances inside the virtual hub. How do you manage the scaling inside the, for the managed NVAs inside the hub?
So assuming that we've got the hub sized correctly already, which obviously is something that is more on the initial side from the Azure standpoint. But in the case of scenarios where we need to scale beyond what we do in the NVA, there's really 2 directions that we can scale that in. So when you deploy an NVA, you're going to choose a number of scale units that's going to dictate the instance types that these 2 instances use. And from a tunnel scale and throughput perspective, that could be one of the options that we've got listed here, that it's going to determine, based on the scale units, the actual amount of throughput that you're going to get per cluster member. Now, obviously, in the case of resiliency, we want to always size for n+1, so that if we have, for example, a maintenance event or something like that that causes one of these edges to go offline, that we could still accommodate our throughput. So in the case of vertical scaling, we can, of course, replace one of these. So you have the ability to deploy multiple NVAs into a single vWAN hub. So we could, for example, add a new, bigger one that has a higher number of scale units associated with it, add that to the cluster and rebalance things. So we've got tooling, for example, within the cluster that allows us to say that if I've got edges connected to the old one, I can evacuate those cluster members and move them off onto the new one before I decommission the old one. Additionally, we can scale this horizontally too. So even though each managed NVA instance effectively is a pair of edges, we can actually have up to 8 edges in a cluster within our solution. I know that there's a vWAN hub limitation of up to 3 NVAs, so effectively we can go up to 6 that can all be part of the same cluster. So we could have a cluster that basically then allows us to have, n+1 up to 5 edges at whichever size that I've dictated in that cluster, so that I can scale it out horizontally that way as well. And there again, that's going to be something where, just by virtue of the fact that our control plane is going to distribute branch edges out to different cluster members, that they are able to effectively spread that load out amongst more instances and allow us to scale in both directions.
Okay, so one deployment from the Azure standpoint is 2 instances, but you can have multiple deployments and then aggregate all the instances on the SD-WAN orchestrator.
Yes, exactly. So you'll choose that. So I'm sorry, go ahead.
No.
Oh, I was just gonna say, so when we look at the actual deployment for this, so for the vWAN deployments, we're in the marketplace under VMware SDWAN in vWAN. So when we deploy, that's going to be something that we'll choose that scale unit setting initially as part of that deployment template. It's actually relatively simplistic as far as what we actually end up defining here. But if we look at the actual things that we need to plug in here, the scale units is the main thing. So if I choose, actually I didn't choose a region where I have a vWAN hub. So just for the sake of example, if I choose an existing hub that, again, is hopefully already sized correctly for what I'm actually going to need, but the scale units that we choose in here, again, dictate one of those instance types. So the 2, 4, and 10 are going to map into these different site profile or instance types that that we use. And like Vivek mentioned, that's being updated to support the accelerating networking numbers and things like that, but is not there today for the managed NVA option. But I can pick whatever I want here based on the amount of throughput and the number of concurrent tunnels that I want. And then obviously from the configuration standpoint, the rest is really just pointing it to the orchestrator, so that they're all publicly reachable as far as our hosted orchestrators are concerned. So I can just, for example, plug in the URL of the orchestrator that I'm on here. And then the only other details that I need are the activation keys. So if you remember when we created that edge in the earlier example, it gave us an activation key. So we're going to plug those in here. That's how vWAN knows that once it actually spins up that managed MVA, that the 2 instances that it deploys can phone home and identify themselves to the orchestrator that way so they can get their config. And then just plugging in the BGP ASN I want to use there and the cluster name that's being used on the orchestrator. So then from the orchestrator standpoint, again, really all that we're doing there outside of having the configuration for the edge is predefined in here, so that in the example that we gave, that you know, it'll identify itself with this activation key that we created so that when they phone home, they can get that. But then again, the only other thing that I need to do is go back and either create a cluster, or if I'm adding to an existing cluster, it can just be a matter of adding that edge to the existing cluster and having that as the logical container that we can use to point spoke sites to. So when that comes up, then that's going to have it given everything that it needs from the perspective of being able to both get all of their configuration. Obviously, it's beholden upon me as the SD-WAN administrator to configure things like the BGP peering. So obviously, you know, as part of this workflow, we get what we need as far as where we should be peering, and then can conversely tell the vWAN hub where it needs to peer to, so that when I look at the actual configurations on here, you'll see that the same thing holds true, where that BGP neighbor needs to be configured on this end. Obviously, we need multi-hop in the case of vWAN, since that exists in a different subnet. So that's something that if you ever run across customers that are using our solution and are banging their heads trying to figure out why BGP didn't come up, the max hop needs to be adjusted in these cases, as well as static routes that point to that peering address, just because that is in a different subnet. Hopefully save somebody some time with that, since I see a lot of customers stub their toe on that. But outside of that, then that's really all that I need. And the hub configurations are pretty simplistic as far as what actually goes on these edges. So we do turn our overlay on. So this Cloud VPN section, it gets turned on here. But there again, on the MVA instances themselves, we don't need to define anything here as far as where they're going to connect to, because again, it's really on the branch to be able to say that if I'm pointing to that Azure vWAN cluster that we were looking at, that it's on the branch side that I point there, and by virtue of the fact that I've done that, then the overlay knows that it can accept those tunnels based on that. So that's effectively it as far as how we stand up the managed NVAs. Are there any other questions on this before I move on to the next one?
I have one more question. It's not in preview
Sure.
anymore, right? Because it says preview on your screen. But I have customers
Yeah,
massively using it, so I assume it's just some cool stuff.
Yeah, apparently this slide is at least 3 years old, because we've been it has not been in preview for a very long time. So apologies for that. I've never really looked at the screenshot we've got. That's actually a screenshot from the marketplace. But if you noticed when we went to deploy it in the marketplace, that has been removed from real life. So that is no longer in preview. So that's a good catch. I think we need to update that one too, Vivek.
Yeah.
Yeah, this is fully GA'd on both ours and Microsoft side. So again, this is something that that gets used by a lot of our customers. You know, obviously we get the benefits of the end-to-end performance enhancements that we do inside of the overlay. So like any of the last three options, you know, we're actually deploying inside of Azure with this. Obviously, this provides us some flexibility as far as the ability to have Microsoft manage the resiliency. And then there are also some benefits from a support standpoint, whereby the VeloCloud support folks have ways that we can do warm handoffs between Microsoft and our support. So it's also something where it's not just going to be the you know, the proverbial hands up, it's not our problem, go talk to Microsoft, or hands up, it's not our problem, go talk to VMware. Type of situations with support. So that's actually something where there is some coordination that happens on customers' behalf between the two support organizations as well, since it is a managed solution with Microsoft. Yeah, Xavier, it looks like there's a question.
Yeah, in regards of the scalability and limits, because the vHub router has like a limit of around 50 gigabits per second overall. Is the vWAN at this point the bottleneck, or how much, you know, aggregated throughput all these the cluster of the SD-WAN cluster can handle for those customers that may be passing too much, you know, traffic? Who's the bottleneck at this point? Is it the vHub router, or how many CPE instances can be deployed to maybe try to max out that you know, how much can customers really push through the vWAN slash the SD-WAN through the vHub?
Yeah, so right now it is the SD-WAN edges themselves that'll end up being that bottleneck. So, and that's because of two things. So first of all, from a performance standpoint, since we don't yet support accelerated networking in this model, you'll notice that the throughput supported on these instance types that we're looking at here, which, if you remember, there was a 2, a 4, and a 10 scale unit model that that map into these three instance types that we see in the data sheet here, the D2D, D4D, and D8D. So you'll notice, and just to point it out, our data sheets are a little bit different for a networking provider in that we have the normal data sheet number, which is like ideal scenario, all 1,300 byte traffic, but then we also have a real world number using IMEX traffic profiles. But these are a per instance number. So being that there is both a limitation in the vWAN hub to have up to 3 managed NVAs, meaning that we get up to 6 instances, assuming that we design for N+1 resiliency, that would normally have me telling a customer that really the 450 megs, just back of the napkin math, we'll round it down and say that that's going to give us a little under 2.5 gigs as far as the amount of throughput that we could really provide that N+1 redundancy for. Now, once we get to accelerated networking, obviously that's going to change the algebra a bit, because you can see that that same D8D instance type, when we can use that, then gets about 5x the performance that we can handle. So that's going to allow it to scale a lot bigger. Will still be the bottleneck and not the vWAN hub router, since there isn't a scenario in which these virtual edges are going to get us to a 50 gig throughput number, even with a cluster of 6 of them.
Great, thanks. So like you said, like as it is without accelerated networking, is about 2.25 gigabits aggregated, and when the accelerated is supported, is going to be about 13.5 aggregated, minus the one that we lose for the redundancy.
Yep, when we're talking, and again, that's talking real world, like actual IMEX user traffic numbers. So I tend not to deal in the data sheet numbers that would tell you that you can actually do twice that potentially, because it's not realistic. But yeah, exactly right.
Thank you.
Mm-hmm. All right. So when we talk through some of the scaling, I mean, we've already talked a lot, so I won't spend too much time on this, just in the interest of time. So the things that we've seen, obviously, that we care about generally when we're scaling, or at least the places where we're going to run into bottlenecks, throughput is obviously one of them. From the SD-WAN overlay perspective, another one is the number of concurrent tunnels. So you'll notice that in our public data sheets, we publish this maximum tunnels number that dictates the per edge quantity of tunnels that they can handle. And again, we're spreading this out with a cluster because the edges in the branch locations are only going to connect and establish tunnels with one cluster member. But those are generally the things that we care about. So, and that's why this horizontal scale, as well as the vertical scale, allows us to kind of combine that and use that to span the whatever capacity we happen to need for a given region. Obviously, we've got customers that outgrow what we can do in a single cluster. So there are scenarios too where we might have multiples, and there's nothing necessarily inherently wrong with splitting up a deployment and doing that. That just is a matter of how I can most efficiently deliver the amount of edges and instances that I need in order to support that. The 10K route support, that's actually going to be typically a bottleneck on the vWAN hub side. We have some customers that do this. Really, the challenge that we have is that while we do support things like route summarization and stuff like that, if you recall, because a branch connects only to a single cluster member, and thereby advertises this branch's prefixes out only this cluster member, so that return traffic can actually reach it because it needs to be connected to the cluster member that the vWAN hub sends it to. There's not as much opportunity for route summarization in these cases because, for example, I can't just say that all my branches are 10 networks, so I'm just going to advertise 10.0.0/8 up through from all of these cluster members, because then the vWAN hub doesn't necessarily know that this branch down here on the left is connected to this cluster member on the left. So while there is still some summarization that can be done there, so that if I have, for example, branches that might be summarized and that kind of thing, that would be potentially feasible, but obviously that can get out of hand pretty quick when we're talking about thousands of branches. So that's going to be something to be cognizant of. The edges themselves can all handle 100,000 routes, so it's not something that that will ever be necessarily a limitation on the SD-WAN Edge side. And similarly, even in the scenarios where we're using the gateways to connect, they can handle 250,000 routes. So it's not necessarily something that that is going to need to be considered there, but that's part of it. So, those are the main things that we tend to consider when scaling. Within the SD-WAN solution itself, I mean, there are other aspects in the overlay. Obviously, one of the big benefits of us hosting both the management and control plane standpoints is really just that customers need to stay within the published numbers that we've got. So, that generally is going to mean, less than 20,000 edges in a single orchestrator instance, less than 100,000 routes inside of the overlay, those types of things. But if they're staying within that, then all of the scaling for the management and control plane components are handled by VMware. So it's not something that they generally need to worry about. And obviously specific to connecting to vWAN, again, throughput, concurrent tunnels, and the route scaler are usually the three things that we end up trying to design around. As far as connecting to that. As far as the connectivity options, one of the workflows that we've seen, especially in cases where customers have locations that are in countries that might not have good peering to the rest of the world. We see this a lot in Southeast Asia, so certainly in parts of Latin America, where there would be an Azure region there, and obviously extending the Azure backbone into that region. And whereas the normal workflow for SD-WAN, when we're connecting two branches together that, for example, would have connectivity, normally they would just be establishing dynamic site-to-site tunnels directly between one another and using whatever transport they happen to have in place in order to do that. Now, that obviously is great when we're talking about sites that have decent connectivity between the two. But in those scenarios where, if I'm, for example, a branch in India and I'm not buying a tier 1 ISP connection there, that connection might go across a peering point that's heavily congested and generally unreliable. Whereas if I can connect in country to an Azure region and use that, then that obviously might provide me better connectivity. So we provide mechanisms that both allow us to be intelligent enough so that, for example, if I'm 2 branches inside of a given region, that I can establish those dynamic site-to-site tunnels there. And but then for connecting to sites outside of that region, and we don't have time to go into exactly how we configure this, but to connect to sites outside of that region, then I can leverage my connectivity up through a hub, and then by virtue of the routes that I learn inside of vWAN, traverse the Azure backbone, and then go back out in that destination region to actually then ride SD-WAN back out to that branch site. So that's a workflow we've seen in scenarios where, in general, the performance is going to be better traversing the Azure backbone than some of those in-country peering points that again have not necessarily kept up with the growth of population in certain areas. Any questions on that before I move on to the next one? Cool. Another thing that that we've seen a number of times now, there's been a lot of work that we've done, especially with a couple of customers that I work with pretty closely, to facilitate the use of the SD-WAN overlay via an ExpressRoute. So when we deploy the managed NVA option, really what you get out of the box there is a LAN interface that we use to peer back to the vWAN hub, and then an internet-facing WAN interface that we use to connect out to the internet. But in the scenarios where customers are still using MPLS, which, you know, obviously a lot of customers are looking at SD-WAN as an alternative to that, but we still do have quite a few customers actually that run hybrid networks where they're just using the internet to augment the bandwidth and expand that, but might still have the MPLS network or even a Metro Ethernet network or connectivity to an in-house data center with other connectivity that is present there. And in those scenarios, there's been a desire expressed to be able to leverage both options as far as I'm paying for, obviously, the internet bandwidth that I get by virtue of the rates that I pay for the managed NVA, and I'm paying for this MPLS bandwidth, so why wouldn't I want to utilize both, right? So, so we actually have mechanisms within here that, in addition to the internet-facing WAN overlay, which there's really not a lot to configure when we actually look at the SD-WAN configuration that goes into that. When I activate an edge, you know, we have this overlay definition that if I designate it as a WAN link, so, you know, I can just tell it to auto detect that WAN link, which effectively just means that I'm going to have the edge on that link going out and connecting to one of our cloud gateways, so that that, you know, again, we would do that anyways just from a control plane perspective. But by virtue of connecting out there, then we can also do things like the gateway can see what public IP that came from. So we're able to detect what's in use there from the NAT. So we can tell the rest of the overlay that if you're building tunnels to this, don't use the internal 192.168 address that's assigned to the interface itself, then actually use that public IP. Whereas with the private overlay, we can configure that manually, where basically we can designate an interface where we would then add a WAN overlay that that we would designate as private, and configure that here. So effectively, that means that now I can also have the SD-WAN Edge know that it can try to build tunnels as private links, basically just meaning that we're not assuming that NAT is going to be taking place there or anything like that, but then build those tunnels to go out through the ExpressRoute and then leverage that MPLS network that might be connected, or that that whatever that underlying transport happens to be via that ExpressRoute. So that means that in the scenario where we've got both, that we can actually end up building 2 tunnels, and then, like Vivek was talking about before, we'll actually be able to distribute traffic across both, so that on a packet by packet basis, then we can leverage the path that's going to both have the best performance and aggregate that throughput, so that we can leverage all of the bandwidth that we're paying for in these scenarios. So really the only thing that's needed in order for this to work outside of the SD-WAN and telling it to build tunnels that way is that on the customer's end, they don't always do this from the perspective of the actual MPLS provider, but there's going to be an interface IP that gets assigned to this SD-WAN edge on the MPLS network that that needs to be advertised into the vWAN hub. So that's something that when they're actually defining what is going to be advertised towards the ExpressRoute gateway and redistributed back into the vWAN hub, that that those IPs that we're going to be building those tunnels to need to be included in that. So not just the internal LAN IPs for the branch, but the actual destination IPs that we'll be building that tunnel to. Because from the edge's perspective, obviously you can start sending traffic towards that WAN IP to build its tunnels, but the vWAN hub, of course, needs to know that it needs to route that traffic out through the ExpressRoute gateway. So that can be another consideration from scaling perspective, because obviously the ExpressRoute gateway has its own limits as far as the number of prefixes that it supports. But outside of that, then just making sure that there's end-to-end reachability between this interface that we would build tunnels off of in the hub and this WAN interface that exists in the branch are the only things that need to be in place in order for that to happen. So I'll pause there too. Any questions on that particular model?
No, but thanks, Luc, for presenting it, because this is really valuable and not often known by customers. So it's great that we have a way and that you're presenting how to achieve that. So thank you.
Yeah,
couldn't
absolutely.
agree more. Really a fantastic use case that you've shared here, Luke.
Yeah, and you'll definitely, if you have customers trying to do this, obviously we're here to help where we can, but you'll see a lot of them stub their toes on this because there are a couple of dependencies that they don't always consider there. All right, so the other option that we had covered in here, so again, going back to this, when we get down to the bottom, and I'll update the Vic slide for it and change that to DMPO, but the what we call a transit VNet, and not necessarily in the same parlance as Microsoft, because this is really a spoke VNet in vWAN parlance. But the idea here being that it is deploying our edge instances outside of the vWAN hub. So there is a customer-owned VNet in which we are going to deploy the SD-WAN edges that will then peer with the vWAN hub. So the edge deployment themselves is going to look effectively identical. So if we were to look at two edges in the orchestrator that have both the managed NVA, like these guys do, and as well as the I've got one in here somewhere, the VNet peer test, or an edge that's deployed in the customer-owned VNet. These configurations are going to look identical, because there again, really all that we're doing on here is deploying the edge, assigning interface IPs, and then telling it where it's going to connect to. So the BGP configuration looks effectively the same, because that the peering IPs are going to be the same as if I was deployed in the hub. It's going to use the same ESN. No real difference there. On the Azure side, it's going to look a little bit different. So obviously I have to have a VNet to start out with, and I have to have that VNet attached to the vWAN hub. So that's a step that needs to be taken if there's not already one in place to do other things as far as getting in and out of the vWAN hub. So that obviously provides us a little bit of flexibility in the sense that we talk about the VNet route table and the attachment there being how I can dictate. So that means that I'm not necessarily having to use the default route table, which when I deploy the managed vWAN, I'm always learning from and advertising to the default route table. I could do that in this case, but if I'm trying to play other tricks elsewhere, I don't necessarily have to. So that has to be in place. The deployment looks a little bit different on the Azure side. So when we're deploying into a customer-owned VNet, as opposed to using this marketplace template, we've got our own ARM templates that we publish that can be used. So it's pretty similar data that we're gathering when we go and look at one of these templates. If I can get this to load. So the additional information that we're providing here, though, is that I can choose my instance type. So this is why when we talk about the support for accelerated networking, there are some limitations, and Vivek will touch on this at the end as far as using the V2 instance types and the drivers that we support for accelerated networking. But in a customer-owned VNet, I can deploy obviously any kind of instance that I want. So, we've obviously got our list of supported instance types that are alluded to on here, and our documentation has the full names as well. But I can pick the instance type that I want to deploy. The version that I choose here doesn't necessarily matter, because again, the first thing that an edge is going to do when it phones home and activates is going to be to see what version the orchestrator has assigned to it, and it'll upgrade it to that version, whatever that happens to be. The rest is pretty similar in the sense that the VCO or orchestrator that I connect to, I just need to plug its URL in there. The activation key that we looked at before is still the same thing. I do have to have a public key that would be used for accessing the instance from a CLI perspective. In this case, again, it's not something that I need to do because there's no configuration or anything that is a critical path as far as deploying an edge that I need the CLI for. But again, some folks like to use that from a troubleshooting standpoint to do basic debugging, and it's another way that I can do packet captures, even outside of the orchestrator. And as kind of an aside there, we try to keep most of the common workflows that I would need from a debugging perspective available in the orchestrator. So if I go and look at the diagnostics for an edge that's actually deployed in Azure, a lot of the basic stuff that I would normally be troubleshooting on a CLI can be done via this diagnostics view, where I can actually have the orchestrator reach out to the edge and look to see things like, from a BGP standpoint, are my BGP adjacencies up right now, so that what I would normally jump on the command line and do a show IPBGP for, that I can actually see the summary of what's going on with my neighbors here. I can see what routes I'm advertising to a particular neighbor live from this edge. So these are all things that I can do from the command line as well. But again, assuming that, oops, grabbed the wrong verb there. So that assuming that that edge is connected to the orchestrator, that I can do that all from here. And in fact, a lot of the dashboards that we have in here are also intended to provide a quick view into that as well. So that if I want to see, for example, the just BGP neighbor state of edges that are in my deployment, that I can see from the different edges, like these are a couple of the vWAN clusters that we've got in vWAN hubs, that I can see that the BGP session is established, see how many prefixes are learned there. Similarly with the gateway connections, this is the one that we were looking at before, where I can see that BGP is up. I can actually, in the case of gateways, see things like the received and advertised routes here as well. So we try to build a lot of that tooling into the orchestrator. But again, that's what it's asking for when we look at this deployment for that SSL key, is to be able to SSH to that instance if we prefer to do it that way, or if there's something like I screwed up my security groups or NSGs that are associated with instance, and I cut it off from the orchestrator or something like that. It can be a good lifeline sometimes to help with that troubleshooting. But outside of that, I can use this template to assign the interface IPs, so that I pick the VNet and subnets that I want to deploy to. But that's really the only additional detail that we wouldn't already have to do in the marketplace style deployment. So what we end up with at the end then is those edges, again, sitting in a customer managed VNet. And then we're still in the same situation where we can peer those with the vWAN hub. So that's going to look more like the BGP endpoint, where I've got this in a different vWAN. But if we look at the hub here, then the BGPs that peers that we've got set up here, and again, this is pretty simplistic from the vWAN side. I'm sure most of you have seen this before, but we're literally just describing our BGP neighbor statement here, and telling it where that VNet connection, because again, when we deploy in this case, our VNet that the edges are deployed to has to be attached to the vWAN hub. So we pick that connection and then just tell it the neighbor IPs and ASN that we are connecting to. And here again, that's going to be BGP multi-hop, which is not the default setting in really any routing device. So another place where you might see customers stub their toe in forgetting to set that. But there's really nothing terribly complex about this. versus the other. Now, obviously, it's beholden upon the customer to pick the correct availability zones and things like that to ensure resiliency in this case, because this is obviously not a Microsoft managed solution. But on the flip side, that also gives customers access to do things that they can't necessarily do in the managed version. Again, allowing them to pick their instance types if they need to go in and actually change an existing instance to upgrade it versus just redeploying and paving over it. All of that stuff is done just via the normal Azure Virtual Machine workflows that we all know and love. So this one is becoming more common with customers. And I think is a workflow that we'll see more of a lot of times due to when we get into some of the security use cases, which we'll kind of go through. Obviously, when we talk about security in this standpoint, there are a few different aspects to that. One of them is Azure Firewall. So obviously that's something that can be enabled on the hub in order to draw traffic from the workload VNets that we've got up here. So depending on what customers are doing there, whether it's just the Azure Firewall that they're using, that works just fine with either model. But if they're using a third-party NVA in order to enforce those firewall policies, that's where this model comes into play more, because you can't have that in conjunction with the managed NVA for SD-WAN. So those scenarios could drive customers to that. And then again, a lot of times it's just if customers already have an existing deployment where they deploy network services into an existing VNet or have other reasons from a flexibility standpoint to do that, that could drive customers to that model. But the scalability standpoint is usually the thing that's going to drive us there, because again, that accelerated networking gets you a lot more capability from a throughput perspective when we deploy this way and can use accelerated networking. Any questions on this one before we flip back to the security conversation?
Yeah, I have one question, but maybe then you're going to address it in the security chapter. One driver for this design, so having the SD-WAN deployment in a spoke VNet, in a spoke of the V1 hub, is also for the compatibility with routing intent. So I don't know if this was the next topic for you or not.
Yeah, effectively, and that's what I was alluding to as well with like the third-party security appliances. So both by virtue of the fact that the routing intent when we're deployed as SD-WAN in the vWAN hub limitation, as well as the fact that again this gives us some flexibility as far as choosing a non-default route table that we can use in that scenario.
So when using routing intent with Azure Firewall to secure the flows, it's possible to have the SD-WAN managed NVAs inside the hub. But if it were to be combined with a third-party firewall solution, then the only option to run VMware SD-WAN in V1 is to have the deployment in a spoke, so like on the previous diagram. And that integrates well with routing intent. And at least from our standpoint, this is the main driver we've seen for the adoption of BGP endpoint and NVAs in the spoke, in addition, of course, to the horizontal scaling and manual control.
Yes, exactly. And that, like Vivek mentioned before, we don't really lose anything technically from the SD-WAN perspective by doing that. It's really just a matter of, obviously the managed NVA is nice from a simplicity standpoint, because I can just kind of throw it over the fence to Microsoft and say, all right, I just want NVA, go and make it happen. So there's a little bit more stitching together that happens on the front end, but once it's in and working, then obviously we get that additional flexibility from the security NVA and the routing intent standpoint, and don't really give anything up from the perspective of the SD-WAN. So that's absolutely accurate. Really outside of that, and the security the flows inside of the vWAN hub, from a security standpoint, we generally are relatively simplistic when it comes to connecting to Azure, just because obviously there are often other solutions in place inside of Azure to secure connectivity, for example, from spoke VNets out to the internet. Our SD-WAN edges are capable of doing things like intrusion detection and prevention, URL filtering, malicious IP filtering, that kind of thing. We also have several integrations, both from the perspective of our SASE solution with the secure web gateway functionality that we partner with Symantec, as well as third-party providers like Zscaler on. But realistically, when it comes to using those solutions outside of environments where customers are potentially running VDI workloads or have other edicts in place that would dictate doing something like that with flows coming out of Azure, that's less common than just the conversation around using the Azure firewall and routing intents in order to secure traffic that's leveraging either the Azure firewall itself or a third-party NVA from a security standpoint. So then, Vivek, you want to talk to this one? This is our last one. I know we're a little over time, but
yeah. Thank you, Luke. As previously mentioned, accelerated networking support was a big ask, and from multiple customers. This essentially enables the SRIOV support for the VMware SD-WAN edges, and that needed support for specific Mellanox NICs that Azure deploys in its environment. And that's where we brought in the support in a release called as 5.4, where we brought in the support for Azure accelerated networking for the CX4 and CX5 NICs. Now there is a caveat that we do not support CX3 NICs. Given that in the Azure environment, the NICs are allotted in a dynamic fashion, it is not predictable as to which particular NIC could get allocated to a particular NVA. So if the CX3 NIC gets allotted, the VM would need to be stopped and started till the supported NIC gets allotted. And that's why we made a conscious choice that we will not support. I mean, it can work with the existing vWAN NVA offer. Like if customers are deploying, it could get allotted a CX4 or a CX5 NIC. But if it doesn't, you could have scenarios where you might have to then stop and start the edges, which is not possible, at least with the managed offering, right? And that's why the plan is to create a separate offer with V5 instances under the hood. And this is something that we are currently testing, and we will probably bring it out by end of January timeframe. The other option is, the edges getting deployed in a transit VNet, like Luke was, going into much detail, where customers have the ability to pick and choose an instance. So they can choose, a V2 instance as well, or a V5 instance, and check for, which particular NIC has gotten allotted. In our testing and also speaking with Azure, we understand that the V5 instances more often than not you'll see a CX5 NIC gets allotted, and that's why our recommendation at least is that if customers want to use accelerated networking, they can look at deploying edges with a V5 instance in a transit VNet and connect to a vWAN hub till we get the offer, managed NVA offer with V5 rolled out. And this was going back to the question that was earlier asked. I don't know if it was Xavier, but this will also enable custom. This is kind of one difference between the managed NVA offer and transit, an edge deployed inside of a transit VNet. But if there are no other kind of feature differences, so to speak. Cynthia, Nehali, Xavier, any questions?
This answer a lot of questions. My questions. Thanks.
Thank you.
Thank you.
Yeah, great stuff. Good content. One quick question. I know we're about time, but is there like a quick overview on the process for upgrade? Is that something handled behind the scenes? Maybe you could just shed some share some slide on that one?
Yeah, I'll try to both show you on the slides and then also show you in the orchestrator. So the general process for upgrading software on an existing edge once it's been deployed is managed by the end customer in either scenario. So they have control over what software version runs on that edge. So when I go to upgrade an edge, the actual edge software images are all hosted on our orchestrator. So that's something that at a very simplistic level, in order to upgrade an edge, all I'm going to do is go into the orchestrator and pick that edge and say that I'm going to assign a software version. So this operator profile refers to, amongst other things, the software version that's deployed. So if I take this existing software version that's on this edge and say that I want to upgrade that to our 6.0 release, then I can just pick a software version off of here. This is kind of a messy orchestrator because this is our lab instance, but I can just pick that software version that I want to upgrade to. So this is our 6.0.1 release and assign it to that edge. And once I hit assign, that edge is going to download that image from the orchestrator into a separate partition and reboot into that so that it'll be running that software version. Now, when it comes to doing this in a production environment, one of the nice things that we can do, because we, in most of these designs, are using clusters, is also pre-stage that from the standpoint of, if I'm going to be upgrading this edge on the left first, for example, we've got a mechanism in place where, via that same diagnostic view that we looked at before, I can pick that cluster member out of this list and go into that cluster member, so that prior to actually performing that software upgrade, because that's obviously disruptive to anybody that's connected to it, since we do have to reboot that edge. So that reboot process can take 30 to 60 seconds before this cluster member would come back up and be online again. And while our control plane will detect that that edge went offline and then reshuffle these spoke edges to it, we obviously have to wait for a timeout to happen before that'll happen. So in order to minimize that disruption, we also have the ability in here to go and rebalance that hub cluster. And one of the options that we've got versus just this standard rebalance, which just means that we're just going to reshuffle the deck so that all of the edges that connect to this cluster are just going to pick a new cluster member and just get rebalanced out. But what this allows us to do is also have the option to say that I want to exclude this hub, so that when I do get rebalanced, since I'm going to be performing this upgrade on this edge on the left, I want to rebalance but not have any of the branches use this hub cluster member. So the result of that is that I can just run this, and the control plane is then going to tell any edges that are connected to this cluster member to go find somewhere else to live for now, so that I don't actually provide any service interruption when I do that. So generally, we'll coach customers to do this first and evacuate that cluster member, and then come back over here and assign that software update. But it's really just a matter, again, of taking this and assigning the version that we want, and then letting it download that version from the orchestrator and reboot. So that reboot, again, is the part that actually is going to be what is impactful there. But there again, the actual process is literally just what I just did, is picking that version and assigning it. And we'll ultimately see that once that edge checks back in, that it's going to update its software image and then go back through that reboot process.
Which it would be similar, like other technologies or solutions call it draining. So you just
Exactly.
kind of like drain it to make sure you know there's no connections, and while it is empty, then be able to do the operations, right?
Right, 100%.
Cool, that's cool.
And so between the managed NVAs and the unmanaged one, the version is at par, meaning they're like to like, or is it different in managed versus unmanaged?
Yeah, so we can do this either way. So there's no, they've got effective parity between how we would handle the actual SD-WAN software image that gets deployed there, and the way that we would do that upgrade. So any of the things that I just showed you are doable on either type.
Got it. Good stuff. Thanks, Luke. So if there are no other questions, any other questions, Cynthia or anybody else?
Not on the demo or on the topic addressed. I have a more generic question, but probably I can keep it for the end.
No, go for it. Yeah.
Yeah. So Just wanted to know if you could share what the future of VMware SD-WAN will be now that it has been VMware has been acquired by Broadcom, and if you could, yeah, maybe just give some insights on the product as we move forward.
Yeah, no, thanks, Cynthia, for asking that. That's a concern with quite a few customers. And typically we lead with a vision slide, but I didn't want to add too many marketing slides. But to answer your question, we are, as a business, we exist inside of Broadcom, and Broadcom is continuing to invest in VeloCloud. Specifically, our focus is going to be SD-WAN, or we call it a secure SD-WAN. So build security capabilities in addition to that, augment with SD-WAN capabilities. Secondly, as we see as we see 5G and satellite, we are looking to invest in fixed wireless access and see how we can provide a better customer experience on the WAN with 5G and satellites as those get rolled out across different locations. And one point there that I want to make is that a lot of the broadband in US and other regions is vendors are looking to also offer 5G and are looking at that as a replacement for regions where they cannot extend connectivity. Thirdly, we are looking very holistically on analytics and observability. I don't know if you caught some of the VMware Explore Barcelona news where we spoke about robust AI networking, or VeloCloud RAIN. So the BU is invested in adding more capabilities around analytics, AI, and observability. And then, like Luke mentioned, inside of Broadcom, we also have Symantec, and we are also working on the SASE integration, where we bring in the Symantec capability so that we can offer it as a single vendor SASE to our end customers. So net, we are invested in VeloCloud, and this will continue to be offered to customers for their SD-WAN requirements, in addition to all the additional use cases that we see that the market will head towards.
Okay, thank you.
Good stuff. Yes. So thank you again, Vivek and Luke, for providing us some awesome insights into the VMware SD-WAN solution. And thanks everyone for joining, and we will see you in the next video.
Thank you. Thank you, Nehali, for having
Thanks,
us.
all.
Yeah, bye.